Well, don't let this Bible verse fool you. We're going to talk about the Big Bang Theory. Now, when I say the Big Bang Theory, what comes to mind? Shirley, what comes to mind?
She's not on.
She's not on. I warned her I was going to call on her.
Universe. It's big.
Well,
That's what
okay.
Something out of nothing.
Something out of nothing. Well, yes. Kind of what I'm looking for is does the Big Bang Theory invoke any emotion in you? Like, that's blasphemy. That's straight from the pit of hell. No, you know, I kind of got the sense that this group wasn't going to have that problem. When we teach the class on campus, we have students who think the Big Bang Theory is trying to put God aside and explain everything science. Well, so if I don't have to deal with that, then I'm done. Any questions? Now, when I do this, I like to start with the fact that we, of course, do recognize there was a beginning, and God created the heavens and the earth. We're going to talk about the Big Bang Theory, but before we get to that, we're going to talk about a few other things. Now, on this handout that I gave you on your way in, this side has a quote from C.S. Lewis that I meant to give out when we did the nature of science. And it kind of goes along with Mark's teaching about worldviews, but C.S. Lewis contrasts the materialist view, which I'm going to see someone who holds this view in my lecture tonight. And then also what he calls the religious view, which I prefer to call a theistic view. And so it's just that, you know, if it's from C.S. Lewis, mere Christianity, it's got to be good. I'm not going to read it for you because you can read. But that's something that I wanted to give out before, but forgot to. The other side of that paper will come at the very end of tonight's class. I want to invite you, including those of you who are watching from home, I want to invite you to interrupt me at any time with questions. I may say some things that make sense to me, but don't make sense to you. So feel free to say, what? And I'll say, because. Okay. So I begin with the concept of cosmology versus cosmogony. Perhaps you've heard cosmology before, but I'm not sure you've heard cosmogony before. What's the difference? Well, cosmology is the study of the structure and nature of the universe. Now, because the universe is a little difficult to bring into the lab and experiment with, it's basically an observational science. That's not entirely observational. What is often done is we feed the equations of physics into the computer and we run a model. And if the model gives us what we see out there, then we think our model is right. Has a chance of being right, at least. So it's not entirely just observational, but it's basically observation. We observe what's out there, and we try to understand that structure and nature, what's out there. Any question on that? On the other hand, cosmogony is the study of the origin of the universe. That only happened once, sometime back in history. And Dan is the expert on history, but even he wasn't there or have a full understanding of the history of the universe. So that's the difference, cosmology versus cosmogony. I always emphasize to my students the two words rotation and revolution. Rotation is rotating on an axis. Revolution is revolving around something. So the Earth doesn't rotate around the sun, it revolves around the sun. Well, it rotates on its axis. If you believe the sun's at the center and not the Earth, which that's been pretty much true for a few centuries now. All right, so those are the two things we're going to look at. We begin by looking at the biblical cosmogony. The Bible gives a revealed cosmogony. It's not based upon observation or experimentation. It was revealed to Moses at some point, and he wrote it down in Genesis. There are other places in the Bible, the Old Testament especially, where you will see things about the origin of the created order. And because there are similarities to other ancient Near Eastern creation stories, some people have boldly claimed Moses got nothing new. All he did was use what was already there in the ancient Mideastern cultures. However, there are some very important distinctives about the biblical cosmogony compared to the other ancient Near Eastern ones. Now, there are elements of the ancient Near Eastern. You know, when you're writing to an audience that's familiar with a culture, you need to write within that culture. So there are similarities, but there are some significant differences, and I'm going to talk to you about that. First one is that God is totally distinct from his creation, although it only exists through his power. The other ancient cosmogonies, parts of the gods became parts of the universe, parts of the created order, as they whacked each other off with swords. Well, in Hebrews chapter 1, verses 2 and 3, we read, in these last days he has spoken to us by his Son, whom he appointed heir, the heir of all things, through whom also he created the world. He is the radiance of the glory of God and the exact imprint of his nature, and he upholds the universe by the word of his power. After making purification for sins, he sat down at the right hand of the Majesty on high. So he is separate from his creation, but he is the creator. And this is referring to the Son, Jesus, the agent of creation. It says a lot of things about the Son here, by the way. The heir of all things, created the world, upholds the world, and I find it interesting. How does he uphold the world here? What's it say? Pardon? By the power of his word. And how are we told in Genesis 1 that God created? By his word. Now you can take that literally, that Jesus is continuing to speak, or you can take it figuratively, that he does it without stress and strain like the other gods did as they fought with each other. They're creating parts of the universe. And the last phrase here I love because, when it describes this one who is the Son in all these ways, after making purification for sins, what did he do? He sat down at the right hand. Now, I always say, Kevin here's a nice guy. He might take a bullet for me, but I don't think he's got the power to save me from my sins. Jesus did. Because of all the things that are said about him here, he has the power to provide purification for my sins. All right, so God's totally distinct from his creation, but it only exists through his power. The material universe was created ex nihilo and by fiat. Now, I like to use this word because it makes me look smart. And you all know what ex nihilo is? Out of nothing and beyond. By word. If you look at Hebrews 11:3, I find that remarkable. In Hebrews 11:3, in that one verse, both of these are spoken of. By faith, we understand that the universe was created by the word of God. Yeah. So that what is seen was not made out of things that are visible. Ex nihilo. Well, I got really fancy with some of that PowerPoint stuff here. In fact, I go so fancy that I had to have David help me get it to where it more work better. Anyway. The third aspect that is different is that the creation narrative is a portion of a larger revelation of God calling out and redeeming a people for himself. It doesn't just exist separate from the whole story of God's calling Abraham and his people. And Genesis 2:12 is where that we see that. Genesis 1 through 11 is called primeval history because what's described there, the author was not there to witness, nor was anybody there to witness, except there was one old gentleman in our church, now departed, who thought that Adam wrote Genesis because he was the one who was there. But anyway, that's not common. Genesis 12 starts out, now the Lord said to Abram, go from your country and your kindred and your father's house to the land that I will show you. And I will make of you a great nation, and I will bless you and make your name great so that you will be a blessing. So Genesis 12 starts the narrative that is actual history, not primeval history. Oh, look at that. It's thick.
That's fancy. That's fancy.
The Creator is the single triune God. Not many gods, as was the case with what are some of those ancient Near Eastern creation accounts? Enuma?
Yeah, we have these Russian literature and the Cosmogony of CCCM and a whole bunch.
You've read them.
Most, yeah, I've read all those.
Good reading.
I haven't read all of them. There's a lot.
Okay. Well, Genesis 1:2 is not on my sheet here, but that's in the beginning God created the heavens and the earth, and the Spirit of God was hovering over it. Yes, basically. The Spirit of God, God the Father, and in John 1:1, in the beginning was the Word, and the Word was with God, and the Word was God. So the triune God was involved in the creative process from the biblical cosmogony perspective. And then finally, and this is, I think, extremely significant, is how different the view of human beings is from those ancient Near Eastern creation accounts. Because, well, you know what the Bible says. Let us make man in our image, after our likeness, and let them have dominion over the fish of the sea, and over the birds of the heavens, and over the livestock, and over all the earth, and over every creeping thing that creeps on the earth. So God created man in his own image. In the image of God, he created him. Male and female, he created them. And God blessed them, and God said to them, be fruitful and multiply and fill the earth and subdue it, and have dominion over the fish of the sea, and over the birds of the heavens, and over every living thing that moves on the earth. As compared with the gods needed someone to serve them. And so they created human beings to provide them with their meals. This is a very different perspective on who we are compared to those. So those are some very significant differences between the biblical ancient cosmogony and the others. I think rule out that those that all Moses was doing was copying. Certainly not. He was really making points. He was making points to show how inadequate those other perspectives that they had lived with around them By the way, when was Moses writing this stuff?
They're wandering around the world.
Uh-huh. And how long had the people been in Egypt under slavery?
400 years.
400 years. And what kind of culture were they immersed in terms of religion in Egypt? Sun god as one of many gods. Everything had a god associated with it. So as the people were leaving Egypt and that culture, what did God realize they needed to know? Did they need to know modern science about how he created the heavens and the earth? No. What did they really need to know? They needed to know their God. So all this is about who their God is compared to these multiple gods that were worshipped where they had been. Now, all these ancient cosmogonies are not really science, including the biblical one, because they're not testable by observation, experiment, or calculation. They don't fit with what we would call science today. By the way, I'm keeping in tune with Andy Whipple by wearing a t-shirt. I had a different one on last week, which that failed, so I didn't wear it again in case another tree would fall. Ancient cosmogonies also do not predict or interpret the phenomenon that we actually see in the distant universe. There is nowhere in the Bible that speaks of quasars or even hints of quasars or galaxies. Of course, wasn't that long ago, we didn't know there were other galaxies. And the ancient cosmogonies claim to be final and complete and hence not subject to further inquiry. So the job of the scientist, if that's what your science is done. There's nothing else to find out because the Bible or your Illuminati has said it all. Any questions about that? This quote I got from that thick book I showed you at the beginning, well, back when I did the, I guess, the nature of science, understanding scientific theories of origins, big, thick textbook they use at Wheaton, and we're using it in the course now, apparently, on Tree, at least part. But the point for them is that God's universe is an ordered creation with several regularities and persistent patterns expressing the nature of God that God has given it. These regularities are examples of the functional integrity of creation, enabling the universe to function as God intends, and these regularities provide means for astronomers to understand the origin of the universe and the way it works. When I was talking about the nature of science, pointed out that the scientific revolution took place in a culture where it was dominated by a Judeo-Christian worldview that believed in a single God, not many gods doing their own things. But this idea of functional integrity, we talked a little bit about that in the past. But in the perspective of the authors of this book, the creation of the universe, the story of creation is more a story of creating function for the world that will eventually be inhabited by us. That it functions as it's supposed to. When he said, and it was good, he could have been saying, and it functioned the way it was supposed to. So, on to the Big Bang, which I have to admit is just science's best guess about this creation of the heavens and the earth. It's a pretty good guess. It hasn't always been here. I'm going to talk a little bit about the history of where it came from. You might be surprised where it came from. But I used to use a textbook by this fellow Hartman in my taught astronomy. Very honest statement that he makes here. Not all scientists are honest about their statements, but he's willing to say that the Big Bang is our creation myth. I like the way he defines myth. A story widely told and widely believed. Not necessarily true or false, but a story widely told and widely believed. Modern man's creation myth is the Big Bang. Almost certainly gives us an indication of some events that actually occurred long ago, but the word myth should be kept in mind to remind us that this is only our best guess of a grand mystery. We scientists don't have final answers. You know, if the scientists had final answers, they'd be out of work. We call it job security. We're going to take that picture. I'm about to move on. Now, interestingly enough, when we talk about the history of life on Earth, where do we go? Where do we find that history of life on Earth?
Physics.
Huh?
We dig.
We dig. The fossil record, right? Sort of a time machine, but in astronomy, we got a really much better time machine. You see, the speed of light, or the speed of electromagnetic radiation, of which light is just a tiny part that our human eyes are sensitive to, is finite. So that when a star, like our sun, emits light, it takes 8 minutes to get to us. God could turn the sun off and we wouldn't know for 8 minutes. But then it'd be really bad. So the farther out in space that we look, the further back in time we're seeing. So we can actually look back in time as we look further and deeper out into space. And our telescopes that are in orbit above the Earth are looking really far. Really far. When we see a galaxy that is billions of light years away, we're seeing it as it was billions of years ago, not as it is now, but as it was billions of years ago. And so this picture kind of portrays the idea of looking through time back to the beginning, the dawn of time. I don't know why that's represented. Oh, that's not a light bulb, it's a question mark, a shiny question mark, which is appropriate. All right, so this is very important. It is an observational science, but we're observing the past. With everything, every picture we take of the universe, we're seeing the past, not the present. And the farther we look, the farther past down in the past we're seeing. So where does this concept of the Big Bang come from? Prior to 1920, the universe was considered to be static. Didn't change in time or space. Hence, it had always been here. There was no need for a creator. Science was happy. Most atheistic scientists were quite content because there was no beginning. And hence, you didn't have to deal with a beginner. Einstein's general theory of relativity, by the way, when was Einstein's general theory of relativity published?
The teens,
Pardon?
was it teens?
Uh-huh.
18s, 13, or something like that?
In 1300s?
19, 13, something like that.
Very close, very good. 1915. By the way, Einstein, I have a lot in common with Einstein. We're both men. But in 1905, he published 4 or 5 significant papers. One was the special theory of relativity. I found an old book I think I've had since I was in high school. I was a nerd. Still, I'm all right. And I like to read about relativity and quantum theory because it was so bizarre. So I have this book and I found it on my shelf. The cover's off of it now. It was written by Albert Einstein. He was trying to explain to the layman his thinking as he developed the special and general theories of relativity. Special theory of relativity, 1905, took 10 more years to generalize it. Einstein received 1 Nobel Prize. Anybody know what that was for? You would think it would be for his peace. Huh? His peace. No. No, it's in physics. It's in physics, but it's not. It's not relativity. You would think how general and special relativity are so well known as Einstein's work. He received the Nobel Prize for explaining the photoelectric effect. Yeah. I always had something to tell my students that they didn't know. And as I always say, if I didn't know the answer, I'd make it up. They'd never know. So Einstein's general theory of relativity, when applied to the universe, indicated that the universe would not be static, that it would either be expanding or contracting. To stop that, he threw in a fudge factor to keep it from expanding. He threw in a fudge factor because he so believed in the prevailing worldview of a static universe, not a created one that had a beginning. Oops. He would later have to admit that the fudge factor was the greatest mistake of his life. But at least he admitted it. Now, of course, why did he have to admit it? Well, let's get to that. It's because in 1929, Edwin Hubble demonstrated that the galaxies were in fact all receding away from us, except for a couple of local ones. And the rate at which they were moving away from us was proportional to how far away they were. The farther away they were, the faster they were moving away from us. Now, that doesn't mean we're at the center. Because you could go and plant yourself in any other galaxy and you'd see the same thing. All the other galaxies would be moving away from. So the universe was not static. It was expanding. Now, here is an explanation of how we know that they're moving away. When we see the light from a galaxy, or from the sun for that matter, what we see are what are called absorption lines in the continuum spectrum. And the faster the object is moving away from us, you're familiar with the Doppler effect? If you're sitting at the railroad crossing, when the train comes blowing its whistle, it's high pitched, and then when it leaves you, what happens? It goes to a lower pitch, all right? Same thing's happening here. If it's moving away from you, the indicated spectral lines are moving further towards the red, longer wavelengths if it's moving away. If it was moving towards you, they'd be shifted towards the blue. We call this redshift. Wonder why. So this is a galaxy that's fairly close. This one's further away. This one's further away yet. And the last one's further away yet. So you see, the farther away it was, the faster it was moving away, because the more was the spectrum shifted towards the red. This shows you Hubble's law. This has 5 galaxies on it. And this is the actual kind of data right here. So this above and below is what we call a comparison spectrum from the laboratory. And this is the spectrum from the galaxy. There's a couple of spectral lines. We call them absorption lines because as the light was escaping the atmosphere of the stars, it was absorbed by the atmosphere. And hence there's missing light of a particular wavelength, particular color, if you prefer color rather than wavelength. And so we see this one is only 63 million light years away. Now, let me pause and explain the light year. It's not a measure of time. A light year is the distance that light travels in a year. What's the speed of light? Anybody happen to know?
180,000.
Close?
186,000.
186,000 miles per hour, or 3 times 10 to the 8 meters per second. All right, at 186,000 miles per second. Miles per second.
Threw me off.
I did. Well, why didn't you give me the answer in the first place?
You're
186,000 miles a second. So if I flip the light switch, in 1 second, that light is 186,000 miles away. Light's fast, but not infinitely fast, which is key to our being able to look into the past of our galaxy, our universe. So when we say it's 63 light years away, that means the light that recorded this spectrum left that galaxy 63 million years ago. The next galaxy is farther away, 990 billion light years, and you can see that its spectrum has shifted farther. This one is 1,440 light years away, and it's shifted even further. And there is then exactly a linear relationship between how far away a galaxy is and how fast it's moving away. I mean, math doesn't get any simpler than this. The velocity of recession, v, is equal to some constant. I wonder why it's h. Hubble's constant times the distance d. Very simple linear relationship between the velocity of recession and the distance away through the value of Hubble's constant. Now, determining the value of Hubble's constant has been an effort for a very long time. Because first of all, you can get this velocity fairly well from how far the shift is. But how do you measure the distance to these other galaxies? You got a very long ruler. Now, there's something called candles. You know, a candle is light. The further away from it you are, the dimmer it gets, right? And so there's standard candles. Some stars are variable. Their light intensity varies. So if you were plotting the light curve, it would go up and down, up and down. Turns out there's a definite relationship between the frequency or the shift of that frequency of changing intensity to the actual brightness of the star. And so these standard candles are what we use to determine distance. Now, obviously, there's room for uncertainty. By the way, if you're in physics or science, there's always error bars. We call them error bars because our data can't be right there. It's got to be.
Never been able to really test that theory with an actual distance.
Actually, we have.
We found a star.
Yes, there are some stars that are close enough that we can measure their distance by a trigonometric method called parallax. So if we look at the star from this side of our orbit and we see it, and then when we get over to the other side of our orbit, we see it, we can measure that angle and use trigonometry to figure out how far the star is away. And so that was done with the first ones. And then they extrapolate and figure, well, all of them will have the same relationship. And Cepheid variables aren't the only kind. There's also a standard candle of supernovas. Certain kind of supernova, its light intensity varies by a known amount. And you can also determine how far away it is from supernovas. But anyway, so the value of Hubble's constant has been worked on many times, and it's getting better and better. But we don't need to worry about the value of that right now. So the picture is of an expanding universe. From some singularity point in the past, already said this,
Smaller than that.
all up to that, to here we are today. So the universe is not static, it's expanding.
So does Hubble's law indicate then that the universe is not just expanding, that it's accelerating?
Get there, because you're exactly right. We discovered that more recently, back in the, I think in the 1990s, they discovered it. Whoa. Whereas we assume that because of gravity, it would be slowing down. It's actually speeding up.
But that's not Hubble.
There was just something else.
No, that wasn't Hubble. No, he was dead by that time.
He was something.
So he stretches out the heavens like a canopy and spreads them out like a tent to live in. Isaiah 40:22b. That's one of 10 quotes from the Old Testament that indicate that the Bible knew about the expanding universe before the scientists did.
Oh my gosh.
So along comes the fellow to try to explain this, Georges Lemaitre. What do you notice about Georges? You probably know which one's Einstein. Georges Lemaitre is the other one. What do you notice about him? He's a priest. He was a Vatican astronomer from the Vatican Observatory. Oh, you mean it wasn't an atheist that's trying to explain away God?
What do you
I don't
think?
Well, he wasn't a Presbyterian, that's for sure.
He was Jesuit.
It was Jesuit. Okay, thank you. So what was Lemaitre's hypothesis? Well, its rudiments are the universe is expanding from an explosion of the primeval atom, which was that big or smaller. Notice the word explosion is in quotes. It's not like a grenade bursting in our room, in this room. The whole universe was in that tiny singularity point. There was nothing else outside of it. I personally believe there was somebody outside of it. But that was the whole universe. And the universe just started expanding inaudibly, not like an explosion. So that's why it's in quotes, okay? And Lemaitre called it a primeval atom. I guess that's real good evil, prime evil, real good evil. Anyway, the primeval atom was incomprehensibly dense. The whole universe was in that one point. Now, if you can't fathom that, it's okay. I don't know who can. And that's
I'd like to point out that people that don't believe Noah could have gotten all the animals on the ark do believe that the universe was in a point.
I give one.
Don't still believe that, but they now, new physics say it needs to be the size of like a peach ball.
Okay.
Oh, really?
Yeah, that's what Spencer. Said. That's in the last 10, 15 years.
Spencer took my place in the class at Montreal.
That's a little bit harder to believe than Noah's Ark.
Yeah.
Okay. And I have worked out how much space each animal will have on Noah's Ark, and I have a hard time. But anyway, the primeval atom was incomprehensibly dense. The whole universe was in that one point. Now, if you can't fathom that, it's okay. I don't know who can. And that's And for Lemaitre, he said it began expanding 10 to 20 billion years ago. We didn't really know exactly, but it wasn't recent. It wasn't 10,000 years ago, 10 to 20 billion years ago. Now we can run this expanding universe backwards because the presently known laws of physics will work as the universe gets smaller and smaller and smaller, hotter and hotter and hotter, back to within the 10 to the minus 43 seconds after the Big Bang. Now that's not a whole lot of time, 10 to the minus 43 seconds. I think we're doing pretty good, but we can't get past that 10 to the minus 43 seconds, that Planck time, because we don't have a theory of quantum gravity. Stephen Hawking tried, didn't get it. Nobody has been able to combine relativity, which applies to very, very massive things like black holes, and quantum theory, which applies to very, very small, which the universe would have been. Anyway.
Oh, it's just that the quantum world works almost the opposite of the macro
Right,
world. Like
right.
it works different. It's just completely weird.
Well, they're both completely weird. Relativity and quantum, that's why I got interested in.
But we can observe, we can make observations, but the quantum world it's mathematics. It's known through mathematics, but it doesn't.
It's a statistical theory.
Yeah, things don't work the same way they do.
Right. So that's why we can't apply our laws of physics back beyond 10 to the minus 43 seconds yet. Well, that's pretty close to the beginning. You know, I could write 10 to the minus 43.0000000000000000001 until we get 3 zeros, you know, but I'm not going to. The conditions of extreme high energy prevented atoms from forming for the first 380,000 years. So we had the components of atoms. We had protons and neutrons and electrons forming around, but it was too hot and too much energy that every time they tried to form an atom, the energy would split it apart. Now, because of that, radiation was not free to move through space for 380,000 years. It got tied up in this charged soup and couldn't move. And so we say the universe for 380,000 years was opaque. If you were there and held the hand in front of your face, you couldn't see it because radiation couldn't move through space. That's what the laws of physics applied to this situation say. We'll see if that's true or not. Now, since the early universe was expanding and cooling rapidly, only a few things could form in the beginning. Hydrogen. That's hydrogen as one proton, not a hydrogen atom with an electron. Helium, which is 2 protons and 2 neutrons in the nucleus, or 2 protons and 1 neutron. Then another form of hydrogen called deuterium, which would have a proton and a neutron. And lithium, which is 3 protons. Just a little bit of that could form in the beginning of the universe. And in order to explain all the other elements that we have, see, got more. There was this theory of stellar nucleosynthesis that explains how those heavier elements were formed in the cores of stars. And right now, in the center of our sun, the hydrogen and helium are fusing together and making carbon and nitrogen and oxygen and so on. All those other elements are being fused together in the core of our sun. And in very massive stars, you can fuse even more than that. And then when our sun will not exactly explode, but it will expand out and just keep going. we will be engulfed in it in about 5 billion years, don't worry. And the more massive stars, the gravity eventually wins and they implode and then they rebound in a tremendous energetic explosion. And then some of the heavier elements are fused in that process. I'm going to show you a chart here in a minute. So this theory predicts certain abundances of the various elements. And that abundance is exactly what we see in space. In stars, planets, and galaxies in space. So, I don't know if you can read this, but Big Bang fusion, that was from the beginning, what I told you about hydrogen, lithium, helium. That's all. Dying low mass stars, like our sun, that will fuse some more lithium, some more helium, and some of these. Exploding massive stars, then you get more things that are fused together. Cosmic ray fission. Fission is the opposite of fusion. Fusion puts nuclei together, fission splits them apart. Cosmic ray fission, splitting them apart. Just a little bit. Boron, that's the only way we get boron. How about that? I never liked boron, it was too boring. Merging neutron stars. Now, the centers of some stars collapse into a lot of neutrons. All the nuclei just get pushed together. And that forms a neutron star. It's the whole star in a much smaller volume. And when they collide with each other, that's a very energetic event. And so you see how some of these other elements are born. And then finally, exploding white dwarfs.
Exploding white dwarfs.
What are they? After our sun blows its outer layers off, expands the outer layers out, and engulfs us, what will be left in the center is a white dwarf. That's what we mean by a white dwarf star. It's a later generation of a regular star.
But Lloyd, all those things exist on Earth, and they all came from those other star events.
Yeah,
Way out
yeah,
there.
yeah.
What about the two white elements?
What about that one and that one, huh?
Yeah,
It didn't say.
okay. Are they man-made or something?
We have a chemical engineer here to tell us.
It's been 30 years.
That's PhD waiting to be written.
Thank you. That's a good answer. That's a good answer. Okay, so I'm only wearing this shirt I don't know anything about, all right? Now, interestingly enough, this guy here, Sir Fred Hoyle, was a British astronomer and mathematician who was one of the leaders in coming up with this stellar nucleosynthesis theory, this way that heavier elements were formed in stars. He was an atheist who hated this new theory of a universe that had a beginning. In fact, he hated it so much, he gave it the name, Big Bang. And he did it this way. He was on the radio and he was denouncing this theory, the Big Bang. The name stuck. He didn't like it. He said Big Bang in a derogatory way because as an atheist, he couldn't stand a theory that had a creator beginning. And so, but interestingly enough, as it says here, he was also, he also advanced the theory of panspermia, that life on Earth came from somewhere else in the universe. By the way, I just recently saw that we have Yeah, brought, one nation has actually gone and scooped up some of an asteroid and brought it home. And they have found in that asteroid all 5 of the things that are necessary for life, building life. Well, the thing still doesn't answer the question of how life gets started, but it could have been brought here by asteroids, I suppose. But anyway, in order to avoid the problem of life actually generating somehow naturally here on Earth, they say, well, it started out there and it came here from somewhere else. And what does that do? Pushes the problem further away. That's it. It still has the problem. Anyway, so that's how the Big Bang Theory got its name, from an atheist who really didn't like it. Let there be life. Now, I said that for the first 380,000 years after the Big Bang, by the way, are there any questions? Do I have any time? Light couldn't travel through space. But after 380,000 years, it had expanded and cooled enough, expanding gas is cool. It expanded and cooled enough to where atoms could form, and the radiation then was separated from the matter and could travel through space. At that time, the temperature of the universe is estimated to have been about 3,000 kelvins. Now, the Kelvin temperature scale is the absolute temperature scale, where 0 is absolute 0. And according to one of the laws of thermodynamics, you cannot get that cold. You can only approach it. But anyway, so that's the temperature scale that scientists like to use, especially when they're talking about the universe. So it would have been about 3,000 kelvins. Let's just say that's hot, but not as hot as the sun. And so at this point, radiation is free to move through space. So all the space is filled with this radiation from a body that is at 3,000 kelvins temperature. We know, we understand black body radiation very well. I'll show you some of that in a minute. We know how to deal with that very well. But because the universe has expanded 1,000-fold since then, we would expect to find this radiation not at 3,000 kelvins, but at 3 kelvins. Now, this next slide is really crude. I created it a long time ago with my very own hands, and you can see it was a long time ago with my very own hands. But here we are in our own galaxy, looking out beyond the other galaxies, beyond the quasars, and in the background is this cosmic microwave background radiation at 3K. No matter where you turn your detector in space, you should find this radiation coming in at a temperature of 3K.
So
Yes, sir.
if we're radiating from a central point, is it, at least in theory, possible to turn in the direction and say, that's where it's coming?
No, sir. One of the interesting, and I don't have a full explanation, is that the universe has no center. Because that thing which began to expand was the whole universe. So there's no center. And there's no edge to the universe. The best I can do is say, think of a balloon. As you blow up a balloon, and I used to do this, I would draw little galaxies on the balloon and then I'd blow it up. And they'd all be moving away from each other, but there was none were at the center. And there was no edge. That's the best I can do. So this shows you what I was saying, how black body radiators at different temperatures, if we plot the intensity versus wavelength in this case, we get a definite shape of a curve. And you can see that at the higher temperatures, you get a larger curve, and then as the temperature gets less and less, the curve gets smaller and smaller, but it still has the same shape. And where the peak of that curve occurs shifts also. So for example, this, what is, you might be asking, what's this blue thing? Well, that's our sun. Our sun is actually 5,800 K. Interestingly, the human eye is sensitive to those wavelengths only. Did we evolve because that's what our sun was emitting, to have only that wavelength that we could see? Or did someone design us to have eyes that can only see those wavelengths? It's up to you. So this is the 3K, 3000 K. This is when the light was first free to go through space. And if we had made this measurement then, we should get that curve. Well, now if it's 3K, well, that's 300K. So 3K is going to be a little bit down here. Well, that was theoretically expected. And so a team at Princeton was preparing equipment to search for this 3K radiation from all directions of space. When they were scooped by this pair of guys at Bell Labs using a very crude scope in 1964. Those two guys, Gonzalez and Wilson, accidentally discovered this 3K radiation coming from all directions of space and got the Nobel Prize for their accidental discovery of what the guys at Princeton theoretically knew and expected to try to find. But they beat to the punch by these guys. Now, who were they working for? Gonzalez and Wilson, who were they working for? Bell Labs. Is Bell Labs really worrying about the cosmos? Probably that's not what was on their mind. They were, well, I can't say for sure what they were doing. Trouble is, no matter where they turned their scope, they had this interference, static interference. And they didn't know what was causing that.
Pigeons.
There were pigeons. No, they didn't clean that scope out. Graduate students were brought in to clean the pigeons and the pigeon droppings out of the scope. But that didn't solve the problem. And then they realized, I wonder if that's what these guys from Princeton are talking about. Bell Labs and Princeton were very close. Princeton University are very close together. And they did get together and say, oh, okay, I guess you found it. So this is an actual graph of 3K radiation. The green line is the theoretical line for a body emitting at 3K temperature. Almost not far above absolute zero, right? Only 3 degrees above absolute zero. Now the Kelvin degree and the Celsius degree are the same size, but the Fahrenheit degree is not the same size. Yes?
Bob, when you talk about the 3000 K coming down to 3K, you're talking about time.
Yes.
When you talk about time, does not that equate also with distance?
Well, yes, because as the universe in time is expanding, it's getting larger, yes.
So they can work out where it all started?
Yeah. Back to 10 to the minus 43 seconds.
So eventually it'll disappear because from 3K, it'll be 2K and then 1K.
Bingo.
I don't know.
It's called the heat death of the universe. Don't worry about it. It's not going to happen another time. So the theoretical curve is the green curve here. According to this, all these orange crosses, which are indicating error bars, they're fitting right on the curve. Is there evidence for the Big Bang having happened? Pretty strong evidence, I'd say. Now, Penzias and Wilson, with their, most of these wavelengths do not penetrate our atmosphere. So all they had was a few points over here. Those points were fitting on a 3K line, 3K curve. But we had to wait until we could get above the Earth's atmosphere to get the rest of the data. And Kobe, cosmic cosmic microwave backgrounds. Okay. Anyway, so we got above the Earth's atmosphere, and there it is, a complete curve that fits 3K. Very nice. Well, there's still a little problem. In order to have structure in the universe now, like galaxies, there had to have been some slight ripples in that CMB. It couldn't have been perfectly uniform or nothing would have formed. We had to have slight temperature fluctuations, and we're talking about 30 to 40 millionths of a degree. How do you measure that? Very carefully. It has been done. So we had to find an instrument that we could put above the atmosphere and actually measure these 30 to 40 millionths of a degree differences. They were finally observed by the Cosmic Background Explorer. There it is, Cosmic Background Explorer in 1992. And more precise results then have been obtained since then in 2003 with the Wilkinson Microwave Anisotropy Probe. I hate that word anisotropy, I can hardly say it. WMAP for short. So this is an actual WMAP image of the temperature of the cosmic microwave background radiation. And you can see that there are obviously the blue and purple are cooler, the yellow and green a little warmer, the red spots even warmer. But we're really talking about a few tens of millionths of a degree differences. And they were discovered. And so we could have a clumpy universe, which is good. Because we are clumpy. If we couldn't have a clumpy universe, we couldn't be here. Any questions so far? There have been some good questions.
I'd love to ask a question.
What else did WMAP find? It found that what the composition of our universe is. This blows my mind. 4.9% of the universe is made of stuff that we're familiar with.
Very much.
That's it, 4.9%. 26.8% is dark matter. What is dark matter, you say? Matter that's not very light. We don't know what it is yet. You know, scientists have to have something or they don't have a job. We're still looking for what, trying to figure out what dark matter is. How do we know it's there? It's very grave. Yes. We know it by its effect on matter that we can see. We know it's there, and we can measure the amount of it to pretty accurately, 26.8%. Now, Rick, 68.3% is dark energy. That which is still also not known, but we do know the universe, instead of slowing down because of gravity, is accelerating in its expansion because of this energy that we yet do not know what it is either. So if you don't know what it is, you stay dark and then takes care of it. And people don't have as much trouble with that since Star Wars came out. Yeah, that blows my mind. We've also been able to nail down the age of the universe, not 10 to 20 billion years, but 13.787 billion years is when it began. 13.787 billion years ago. Now, some people who say the Bible won't allow for the billions of years are going to have problems with that, obviously, right? And as Rick has pointed out, the universe is expanding at an increasing rate now instead of slowing down. And this one I just throw in to make you question. The geometry of the universe is remarkably flat. What's that mean? Well, you know what flat is. That's flat. The universe is remarkably like a table. In high school, we all studied Euclidean geometry. Some people hated it. I liked it. My students hate it. But that's the geometry of a flat plane. Turns out there's the geometry of a sphere, different geometry. And there's the geometry of a saddle plane. So, which it is depends upon what's the average density of the universe. If the average density of the universe is 1, then the universe is flat. It's going to expand forever. Well, eventually just stop and stay there. If the universe, the average density of the universe is less than 1, it's going to expand, stop, and there'll be the big crunch. Or if it's greater than 1, the universe will expand forever and ever. And it's always amazing to me that the infinite number of these that could be, and the infinite number of these that could be, it's this. There's only one chance of that. That's all I have to say about that. I know it hasn't answered your questions, but I didn't hear any, so that's okay. So here's the picture of it now. We go back to beginning, and for the sake of science, they call it quantum fluctuations. We call it God. We call it quantum fluctuations. And then there's this period of inflation. And now we know a lot about inflation, but that's a different kind. So the universe expanded very rapidly at first. From 10 to the minus 35 seconds to 10 to the minus 32 seconds, the universe expanded 10 to the 50th fold. Very rapid expansion for a very short time. That enables us to explain a couple of conundrums that I don't even want to get into. But anyway, then there's the dark ages before light was free to move through space. Then we have stars forming. We have a slowing expansion. And then at some point we have an accelerating expansion. Now, my understanding is the acceleration should be a little further back here. That's our best understanding of the universe. Any questions about that?
So is the theory that once dark energy has an effect, it starts to expand more rapidly? Or
Yes. Dark energy was dominant, dark matter dominated dark energy at first. And as the universe spins out, dark energy dominates dark matter.
so they don't.
So Lloyd, did you say that the average density of the universe was 1?
Okay. Yes, it's very close to, the ratio is very close to 1. It's actually a ratio that the actual density to the theoretical density is very close to 1.
But a little variation one way or the other would have.
Right, it would change that. It would change that, yes.
So do we know now whether it's gonna expand and stop, track, or keep going?
No, I don't think we can say yet. And I don't think it matters for us, but yes, it would be nice to have an answer to that. Any other questions? Well, this quote comes from Robert Jastrow in his book, God and the Astronomers. It's my favorite. I'll let you read it. Would you like that? To put it in perspective, let me read to you what this guy, Robert Jastrow, says about himself. When a scientist writes about God, his colleagues assume he is either over the hill or going bonkers. In my case, it should be understood from the start that I am an agnostic in religious matters. However, I am fascinated by the implications in some of the scientific developments of recent years. The essence of these developments is that the universe had, in some sense, a beginning, that it began at a certain moment in time and under circumstances that seemed to make it impossible, not just now, but ever, to find out what force or forces brought the world into being at that moment. Was it, as the Bible says, by an all-powerful hand that creates the world out of formless matter? I don't know what translation that is. No scientist can answer that question. We can never tell whether the prime mover willed the world into being, or the creator agent was one of the forces of physics, or the astronomical evidence proves that the universe was created, he says, 15 billion years ago, in a fiery explosion. And in the searing heat of that first moment, all the evidence needed for a scientific study of the cause of the great explosion was melted down and destroyed. So this is not the writing of a believer. This is the writing of someone who described himself as a materialist. Well, he believes that all the things that are material are real. I've seen this guy on a video. He's in pain. He's in pain because he knows his worldview is in conflict with his observed astronomy. You seen it too?
Yeah, he says in the interview, they ask him if he believes in God, and he says, well, the evidence points that direction, but I can't bring myself to believe.
Exactly.
Like, that's, I'm a scientist, right?
Exactly. Well, I still have time. Well, I'm talking about books. This was an interesting book I read some time ago, Genesis and the Big Bang, the discovery of harmony between modern science and the Bible. Gerald Schroeder is a Jewish astrophysicist who has a very interesting take on the subject. And what I admire about him is for his biblical arguments, he only uses the ancient sages. Long before evolution was an issue, long before the Big Bang was an issue, he uses those ancient sages to interpret Scripture. Secondly, for his science, he only uses refereed materials. Doesn't use stuff that hasn't been approved by the scientific community. Very interesting perspective he takes on it. And this one is The Creator and the Cosmos by Hugh Ross. Some of you probably have heard of Hugh Ross. He is a Christian astrophysicist who has become gives his life to apologetics now, and he writes books and argues for his viewpoint of a universe that is old but created. Now, the handout that I gave you is in this picture here. And this parallels the one I gave out when I talked about the nature of science. Taken from the same author, Joe Rao, Mapping the Origins Debate. In the back of his book, here Ross fits in this category, old Earth creation. His viewpoint is that each day corresponds to a long period of time, the day age view. Now, I'm not going to spend a lot of time talking about this picture. You have it to take home and study it. I remember Rick wanted to have a copy of that thing I portrayed. That's why I created handouts for you, because yeah, there's a whole lot of stuff in this table. And you might want to look at it and consider it, but the two ends of the spectrum, again, notice the spectrum, meaning you can fall almost anywhere along here. But on this end is the naturalistic evolution, which is a totally non-theistic viewpoint. And on this end is the young Earth creation, which is totally opposite viewpoint. In between are other theistic perspectives, and some involving more and more activity of God in his creation. But even this one, on teleological evolution, this basically says God did such a good job when he created, he didn't need to mess with it anymore. But anyway, I will leave that with you. Any other thoughts or questions? I got it done before my time was up. Yes, sir.
Just going to mention something that might be of interest to folks. A couple of, there's a podcast called The Good Faith Podcast, Curtis Chang. It's his podcast, but he did a interview, got it right here. A couple weeks ago, maybe. Well, March 19th is the date of the podcast with Francis Collins and Christine Torgerson. And folks might be interested in that. Only a lot of the relationship between science and faith, and Christian faith in particular. And Francis Collins created something called Biologos.
Biologos.
And Christine Torgerson is the head Biologos now. So anyway, FYI.
Yeah, they would be over here somewhere, this area, planned or directed evolution. They're not old Earth creation. The old Earth creationists don't like evolution very much. But everyone that has the word evolution does. They're happy, they're content with evolution. So that's the Good Faith podcast from a couple of weeks ago.
Yeah.
Thank you.
Well, I have a question a little bit off the beaten path, but question of whether if there is absolute space or not, or is there only relative space? Where do you fall on that one?
I can fall right here. Well, I just read that little book by Einstein, and there is no absolute space. Everything's relative. It depends on your reference frame.
Yeah, there's some people that one theory, though, that as he developed that, he really assumed the answer to start. He talks about his clocks, the two things moving because he talks about the time going from A to B is the same as B to A, which would be true if it was relative, but if there was absolute space, it might not be true.
Well, yes, of course, you have to start with some presuppositions. And for special relativity, he started with the assumption that the speed of light was the same no matter the relative rate of motion. And that's been proven true. And then in the general theory of relativity, he said that the laws of physics have to be the same in all reference frames, regardless of the condition of how they're moving. And that was his assumption. And so I don't know if that's assuming what he concluded is assuming that laws of physics shouldn't change depending on how you're moving in relation to it.
You left the myth of the multiverses out on purpose?
Well, that comes in another subject, intelligent design. And of course, I would imply that there is evidence that there's some intelligence behind this whole scheme. And that's based upon, well, in Ross's book here, and it's a little dated now, he cites over 120 different parameters of the universe in our solar system and the Earth that have to be just right, or we wouldn't be here. So how is it that in one universe, everything's just right for us to be here? It's like God had, we think it's God. So in his control room, there are these hundreds of dials and gauges, and all the dials are put just right. Some of these can only be off by a tiny, tiny fraction of a measure, and we wouldn't be here. So all the dials are set just right. Jose comes in and says, what happens if I turn this dial? We're gone. Jose, don't do that.
We have a question.
Yes.
Thanks, Shirley.
Okay, could you go over the difference between old Earth creation and new Earth creation?
Yes. Old Earth creation basically says that the Bible gives a generally correct order of created things, but it didn't take place in a 24-hour day. Each day corresponds to a long period of time, an age or an epoch. Whereas in the young Earth perspective, each of the days of creation in Genesis 1 are 24-hour days. And so it was a much quicker creation. And of course, Mark will tell you that Augustine said he didn't even need a whole day. Instantaneous. I don't know why it took him a day myself. But anyway, that's basically the difference between old Earth and young Earth creationism. The old Earth creationism says that the Earth is indeed about 5 billion years old. The universe is indeed 13.757 whatever years old. And but it took each day corresponded to a long period of time. Thank you for that question, Shirley. I tried to call on you at the beginning of your class, but you weren't there yet.
I was hoping you wouldn't notice.
Well, I don't get to see you right now, but when I watch myself, which I will do, on our archive, I can see you then. And by the way, did Bob stay awake the whole time?
No. Thanks for asking.
Okay, well, he's had a hard day, I know. Did I answer it sufficiently?
Yes, very well. Thank you very much.
You're being some sense to the way the universe works. There's a really, it's very interesting TV series narrated by Will Smith a few years back, and it was kind of following the lines of evolution. And it was amazing how many times he'd say, boy, at this part of the evolution cycle, we got incredibly lucky because against all odds, this happened instead of that. And it was amazing to me at the end of that series. It's like, how can anyone come to any conclusion other than, if you get lucky several 100,000 times in a row, maybe it wasn't luck.
Yes, and Jose has brought to my attention that there is a movie coming out at the end of April that is produced by the intelligent design people. The Story of Everything, it's called. In theaters, April 30th. The cinematic exploration of the cosmos that reveals the hidden hand behind our universe. That could be a very interesting movie to take your special significant other to. One of you gets to sleep. I will be awake.
What if he goes to sleep the other way?
Really, still on. I think Dave's going to. Anything else?
What's next? Upcoming.
Okay, so next week, because it's Monday after Easter, I thought we would be able to have a class, but our church people don't work, so we will not meet next week. But in 2 weeks, I'm going to talk about the origin of our solar system and Earth. And then I think April 20th, we have Ben Brandenburg, a history professor at the college, who always does the history of the origin debate for our students at the college. He's going to come in and do his little history of the debate. Pardon?
It's now Dr. Brandenburg.
Wasn't he always?
No, he was working on his doctorate when you were there.
Is that right?
Yeah.
She's now Dr. Brandenburg. Now, by the way, I do not have a doctorate. If that makes me diminish in your view, I want to point out my master's degree is in physics. That's not a big deal.
For what, 40 years?
Yeah, I did teach it. Yes, I made up a lot of stuff. But
Are you gonna do one on the creation of Adam and Eve?
oh, that was last week.
Oh, I missed it.
But it's archived.
It's our-
Yeah.
There's no electricity.
Mark covered that kind of nicely last week.
Actually, 2 weeks ago, because we didn't meet last week.
2 weeks ago, yes. Yeah. So, and then we have a session scheduled for talking about the 3 approaches to the issue: conflict, concordism, and complementary approaches to the subject. And then we have, for our last night, we were just going to have an open discussion. At least that's what's planned. And we now will have to, if we're going to do all that, we'll go into May, first Monday in May, because we lost last week. All right, well, our time is now up. Thank you all. Just if you're interested, there's the inflation business. This is the period of inflation, 10 to the minus 35 seconds to about 10 to the minus 32 seconds. How the radius of the observable universe expands so quickly. I included that in case somebody asked me about it, but then I went ahead and talked about that. Okay. Thank you, Lord, for having us be with you this evening in your magnificent creation. We may have some explanations, but we don't have final explanations. We thank you that you love us enough to care about us and provide our salvation in Jesus Christ, in whose name we pray. Amen.